Stand up right now. Don't think about it, just stand. Notice what your body does automatically. The spine stacking, the hips locking forward, the weight shifting from heel to ball of foot. You didn't learn that. You inherited it, and it cost your ancestors around 5 million years of slow, grinding biological debt to give it to you. Every other large mammal on Earth walks on 4 limbs. Dogs, bears, gorillas, the horse outside a barn door. When they need to rear up, they can, briefly, awkwardly. You do it constantly, for hours, without thinking. That gap between you and them has a cause, and the cause is a plant. Around 8 million years ago, the African continent started drying out. The wet canopy forest that had stretched across the center of Africa began to shrink toward the coasts. In its place, something new moved in: grass. Not the soft grass of a suburban lawn, but tall, sharp-edged, silica-bladed grass that grew to chest height and hid leopards. C4 grasses, they're called, named for a photosynthetic pathway that runs efficiently in heat and drought. They spread across what is now Ethiopia, Tanzania, Kenya. Millions of square kilometers of the stuff, baking under the equatorial sun, the stalks clicking in the dry season wind. Your ancestors were sitting in the trees above this. The last common ancestor of humans and chimpanzees lived somewhere in the forests that were disappearing. We don't have its bones in any complete form. What we do have are the clues about what it faced: the forest retreating patch by patch, the open ground expanding between the remaining trees, and a simple problem that every arboreal ape in that landscape had to solve. How do you cross the gap? A chimp crossing open ground does something instructive. It drops to all fours and knuckle walks. Fast, efficient, stable on 4 points. But knuckle walking costs energy. It's hard on the wrists, and in tall grass, it's nearly blind. An ape standing upright in chest-high C4 grass can see over it, can see the lion 30 meters away, crouched and still, can see the tree line on the other side of the clearing. The species that gave rise to you didn't knuckle walk across those gaps. It stood up. Around 6 to 7 million years ago, the first evidence of upright posture appears in the fossil record. Sahelanthropus tichadensis, found in Chad, shows a foramen magnum, the hole at the base of the skull where the spine connects, positioned underneath the skull rather than toward the back. In 4-legged animals, it faces backward. In upright walkers, it faces down. The skull from Chad points down. That's a body balanced on 2 legs. 4 million years ago, Australopithecus afarensis had the full package. Arched feet for absorbing impact, an angled femur that shifts weight over a single standing leg, a bowl-shaped pelvis that stabilizes upright posture in a way a chimpanzee's flat pelvis never could. Lucy, the 3.2 million-year-old Australopithecus skeleton, found in Ethiopia in 1974, stood just over 1 meter tall and walked on 2 legs across a landscape that was 50 to 70% open grassland. The biomechanics tell you why this worked over time, not just as a way to see over grass, but as a way to move through it. A 2007 study by David Sokol, Daniel Rachlin, and Herman Pontzer measured the energy cost of walking in both chimpanzees and humans. Chimps walking upright, which they do only occasionally and badly, use 4 times the energy that humans use to cover the same distance. Your body walking is a machine built for efficiency. The locked knee, the glutes that fire on each stride, the forward lean that lets momentum do half the work. You are the cheapest large biped ever to evolve. You can walk 10 to 15 kilometers a day on a diet that would barely fuel a chimp for 5. That mattered in the grasslands, because the grasslands had food spread across enormous distances. Tubers underground at one spot, fruiting trees 4 kilometers northeast, a watering hole beyond that with scavengeable carcasses. A 4-legged ape working that landscape burns more fuel getting from point to point than it gains in the calories it collects. A bipedal one turns a profit. Standing upright also freed the hands, and once the hands were free, they could carry food back to a group instead of eating on the spot. They could carry an infant without the infant clinging to back fur that was slowly disappearing. They could hold a rock. They could throw it. Vertical body did one more thing nobody talks about enough. It faces the sun on less surface area. A quadruped walking through open grassland at noon has its entire back exposed to direct solar radiation. A biped has only the top of the head and the shoulders. The temperature difference is significant enough that upright posture, in the direct sun of the open savanna, reduces heat load by almost a third. Your body was cooling itself in conditions that would have cooked a knuckle-walking ape. In 1978, Mary Leakey's team found something in Laetoli, Tanzania that stopped the argument cold for a decade. 3 sets of footprints in volcanic ash, hardened by a second eruption that sealed them under 4 centimeters of rock. 3.66 million years old. The prints show an arch, a big toe aligned with the others rather than splayed for gripping, a heel strike, and a forward push from the ball of the foot. They look like the footprints of someone walking on a beach this morning. 3 small upright figures walking nor-northeast, the ash soft under their feet, a volcano somewhere behind them rumbling, the prints filling slowly with fine gray powder before the next eruption sealed everything for 3 million years and change. For decades, the story was clean. Grassland spread, forest shrank, apes stood up to survive the open ground. Grass forced the issue. The evidence seemed to stack up neatly. Then a team led by Alex Peel published a study in 2022. They had spent years watching chimpanzees in the Isa Valley of Tanzania, which is one of the most open, woodland and grassland habitats that chimps live in anywhere. If the Savanna hypothesis was right, these chimps should walk bipedally more often than forest chimps. They live in the conditions that were supposed to select for upright walking. They don't. Isa Valley chimps walk bipedally at the same rate as chimps in dense forest, around 3 to 4% of their locomotion on the ground. The habitat being open doesn't push them toward 2 legs. Something else drove the human lineage upright. The grass was a backdrop, not a trigger. The current best guess involves a combination of factors. Skeletal pre-adaptation, since the common ancestor may have already had hip anatomy that made upright walking easier than it does for modern chimps. Freeing the hands for carrying food in infants. Heat management. Energetic efficiency over long distances. None of these alone. All of them together, accumulating slowly across hundreds of thousands of years in a landscape that kept getting drier and more open and more demanding. Grass set the conditions, the body found the answer. Walk outside right now. Notice the pavement under your feet. Somewhere under that pavement is soil, and under that soil are dead root systems, carbon locked in the ground from 10,000 years of grass cycles. You are walking on compressed grassland. Your feet are shaped by it, your gait is tuned to it, your hips swing in a pattern that was worked out one stride at a time in the Rift Valley while volcanoes erupted and the ash settled soft and gray over everything. You are wearing a body designed by a plant, and it walked you here.